We don't always have to worry too much about the generated code. But in really high-performing situations, it may be necessary to keep the amount of generated code to a minimum. It may also reduce the potential occurrences of any errors. This code here is going to prove an interesting point. In this case here, we have a chain of method calls. First, we have this method called run, which calls compute, that calls load, and then when load has executed all of its processing, it returns the result from the asynchronous operation. All the methods will use the async and await keywords to validate that the method it's calling completed successfully. Compute will await load. Once that is done, it will return the value back to run. Run also awaits that asynchronous operation before it returns a result. If we compile this and look at the generated code, it introduces a state machine for all of the different methods, one for run, load, and one for compute. The state machine, as we saw, introduces complexity. And given this scenario, do we really need to introduce a state machine for each of these different operations? We've learned that we could simply await an asynchronous operation both for the purpose of retrieving the value it returns, but also for validating its success. There is a way to refactor this method chain to make it a little bit better. Notice there's nothing happening in any continuation. They're all just returning a value back to the caller. If we instead remove the async and await keywords and return the task, we'd end up having the same method signature. The application compiles fine, but suddenly we reduced the complexity and less code is generated. If we do this, it's extremely important that whoever is calling run should be the one introducing the await. You must make sure that the asynchronous operation is at least awaited at the top level. If we were to call this in search click, that would be the method which awaits this operation. So even though it's simple for us to introduce the async and await keywords to work with our asynchronous operations more easily, we should be very cautious, and we shouldn't take these keywords lightly. Think about the situations that you're working in, and if there is a way for you to improve the performance by allowing the caller to take care of the asynchronous operation, do that instead. This would potentially allow you to reduce the amount of complexity generated when you're compiling your code. With a better understanding of the state machine and the implications of adding async and awaits, it's now time to proceed to discuss why a deadlock occurs and how we can prevent that.